Assalamualaikum. Welcome to my physics tutorial for high school students. Today's episode focuses on a problem that involves sound intensity and intensity level. So join me as we differentiate intensity of sound such as 10 to the negative 12 watts per meter squared and intensity level such as 10 decibels. Just hang on, watch, and learn. What do we mean when we say intensity of sound? The intensity capital I of a sound wave is the time average rate at which energy is transported by the wave per unit area. The physiological effect of sound intensity is called loudness, but loudness is a subjective description of sound intensity. The physical way of defining or measuring sound intensity is given in this equation. So intensity, capital I, is equal to capital P divided by capital A, or capital P divided by 4 pi r squared, where capital P is the amount of energy per unit of time, and small letter r is the radial distance from the point source to the point sound is detected. If capital P or power is expressed in watts and small letter r in meters, then the intensity capital I is expressed in watts per meter squared. To illustrate intensity of sound, imagine a point, a point source emitting sound energy per unit time or the power P. Assuming that the medium of transmission is air, the sound energy per unit time is transmitted radially outward in all directions. Alright? And supposing the sound energy per unit time is measured over a certain sphere area capital A, which has a radius or a radial radius equal to small letter r from the point source, we can express the sound intensity at surface of sphere as the amount of energy, all right, per unit time or the power over this segment of the spherical area equal to 4 pi r squared. We also emphasize that the intensity capital I obeys the inverse square law, which means that if the distance small letter r from the source is doubled, the intensity is decreased by 1/4 the original intensity. Or, if the radial radius small letter r is tripled, the intensity decreases to 1/9 or 1/9 of the original intensity. sound intensity level, denoted by the Greek letter beta, and usually expressed in the unit decibel. We say that intensity level is actually a logarithmic measure of the sound intensity, and it can be determined mathematically using the formula beta equals 10 times the logarithm value of the given intensity capital I over I naught, all right, where I sub naught is called the threshold sound intensity, whose value is equal to 1 times 10 to the negative 12 watts per meter squared. All right, so this threshold sound intensity is equivalent to 0 decibel. We call it the threshold intensity level. All right, the second equation is used if, for example, you are asked to determine the equivalent intensity in watts per meter squared if you're given the intensity level beta expressed in decibel. All right, so capital I is just equal to I naught multiplied by 10 to the power beta divided by 10 decibels. Okay, so for our first example, supposing there is a sound with an intensity capital I equal to 1 times 10 to the negative 6 watts per meter squared, then we are asked what is its intensity level. All right, so we just use the first equation, beta equals 10 log quantity I over I naught. That is, beta equals 10 times the log of 1 times 10 to the negative 6 watts per meter squared. That's the given intensity capital I over I naught, which is 10 to the negative 12 watts per meter squared. All right, so simplifying or doing your math, we will get the value of beta, which is 60 decibels. Our second example, all right, we have a sound of 60 decibels whose intensity equivalent, I mean, whose intensity level is 60 decibels, and we are asked to find its intensity equivalent in watts per meter squared. All right, so uh, for this kind of question, we will just use the second equation. Okay, I equals I naught multiplied by 10 raised to the power beta divided by 10 decibels, or 10 negative or 10 raised to the negative 12 watts per meter squared. That's the value of I naught, and then multiplied by 10 raised to the 6, because 60 decibels when divided by 10 gives us 6. All right, the unit decibel also cancels out, and with the help of your calculator or even mentally, all right, you can just do the operation. Okay, and that is the intensity equivalent is equal to 1 times 10 to the negative 6 watts per meter squared. So let's now go to our main question. A 10-minute exposure to a 120 decibel sound will temporarily shift your threshold of hearing at 1000 Hz from 0 decibel up to 28 decibels. 10 years of exposure to 92 decibels will cause a permanent shift to 28 decibels. Question letter A. What sound intensities correspond to 28 decibels and 92 decibels? And question letter B. How many times is 92 decibels more intense than 28 decibels? Our solution, we will be using the second equation, all right? Capital I is equal to I naught multiplied by 10 raised to the beta over 10 decibel. Okay, this is to find the watt per meter squared equivalent for each decibel value. For the 28 decibels, its intensity is just equal to I naught, which is 10 raised to the negative 12 watts per meter squared, multiplied by 10 raised to the power 2.8. Alright, 2.8 is obtained by just dividing 28 decibels by 10 decibels. And with the help of your scientific calculator, the equivalent of 10 raised to the power 2.8, alright, is equal to 631. So that will be multiplied to the value of I naught, 10 raised to the negative 12 watt per meter squared, and we get the value for the intensity corresponding to 28 decibels, and that is 6.3 raised to the negative 10 watts per meter squared. Similarly, for the 92 decibels, all right, its intensity is equal to I naught, 10 raised to the negative 12 watts per meter squared, multiplied by 10 to the power 9.2. All right, 9.2 is obtained by dividing 92 decibels by 10 decibels. And with the help of your scientific calculator again, the equivalent of 10 raised to the power 9.2 is in fact equal to 1.6 raised to the 9 power. All right? And multiply that with I naught, 10 raised to the negative 12 watts per meter squared, we obtain the intensity equivalent of 92 decibels, and that is 1.6 raised to the negative 3 watts per meter squared. Now, in answering letter B, you might be tempted to divide 92 decibels by 28 decibels. Okay, since we are asked to determine how many times is 92 decibels more intense compared to 28 decibels. All right. Now, if you do this procedure, dividing 92 decibels by 28 decibels, and get the ratio 3.3, the truth is this is not correct. All right, this is incorrect because in comparing how many times is 92 decibels more intense compared to 28 decibels, you've got to convert them to their intensity equivalent, exactly what we did in letter A. All right? So, we say that this procedure is not acceptable because uh, decibels or intensity level expressed in decibel belong to what we call interval scale. All right? In statistics, there's such thing as interval scale, ratio scale, nominal scale, all right? And decibel or intensity level expressed in decibel belongs to interval scale, all right? It, interval scales are actually measurements that do not have what we call absolute values, unlike ratio scale, all right, such as intensity expressed in watt per meter squared. that is considered under what we call ratio scale. All right. So we say that dividing 92 decibels by 28 decibels, all right, uh, for comparison, that is not acceptable. So what is correct is for you to divide the intensity we obtain in letter A. All right. How many times is 92 decibels more intense compared to 28 decibels? Okay. What we will divide, okay, is the intensity equivalent of 92 decibels. That is 1.6 times 10 to the negative 3 watts per meter squared, and divide it by the intensity equivalent of 28 decibels, which is 6.3 raised to the negative 10 watts per meter squared. So the unit watt per meter squared automatically gets cancelled, and we will just divide 1.6 times 10 to the negative 3 by 6.3 times 10 to the negative 10, and we will obtain the ratio equivalent equal to 2,500,000, okay, which means that the 92 decibel sound is 2,500,000 times more intense, all right, compared to 28 decibels. So that concludes our discussion. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.